Okay, in this video, I'm going to finish going over the midterm review part 2. So we were on number 9, which is from section 2.1. And this problem was this problem is about solving equations that have absolute values in them. So when you are solving an equation that has an absolute value in it, the first thing you want to do is isolate the absolute value. So get it by itself on one side. So the entire absolute value is this entire expression here, everything inside the up and down bars. So we want to get that by itself, so we need to get rid of this 8 here because that is on the same side of the equal sign as that absolute value, but it's on the outside. So I'm going to subtract the 8 to both sides to cancel it on the left. And this leaves me with 11y plus 6, or I'm sorry, the absolute value of 11y plus 6 is equal to negative 6. So remember that the definition of an absolute value is the distance from 0. And distance can't be negative. So just a couple examples. We should know that the absolute value of a negative number, like negative 4, the distance from 0 to negative 4 is just 4. So it makes it positive. The answer is a positive 4. And the absolute value of positive 4 is also positive 4. So we cannot have the absolute value of anything be equal to a negative number. So that is one of the rules. The absolute value of any expression or number x cannot equal a negative number a. This means that it's no solution. It's impossible. Because whatever y is in here, after you plug in any number for y, and you take the absolute value of all of that, it should be positive. So if you get the absolute value by itself and it's equal to a negative number, then it's no solution. So that is a rule. So that's the answer for number 9. Number 10 says same thing. We're doing the same thing, solving the absolute value. This is still section 2.1. So for this one, the absolute value is already isolated by itself over here. And it's equal to a positive number 25. So that's good. So we can continue. So whenever you get the absolute value of any expression, number, or anything equal to a positive a, so I'm going to write this rule here. If the absolute value of x is equal to a, then x is equal to a, or x is equal to negative a. So whatever the expression is inside the absolute value, we're going to take it and set it equal to the positive number it's equal to and the negative number it's equal to. And that's, again, because if we look back at this example up here, if the answer is positive 4, well, the expression on the inside could have been negative 4 or positive 4. So that's why we take this expression, the entire expression inside of the absolute value, and we are going to set it equal to the number 25 that it has right here. And we're also going to take that expression and set it equal to the negative 25. So that's what that rule tells me to do for absolute value equations, if it's equal to a positive number, excuse me, absolute value, which it is in this case. So for absolute value equations, you get it by itself. If this is positive on the right side of the equation, then you separate it into two equations that you need to solve, one with the positive number 25 and one with the negative number 25. And that's how you break away the absolute values. But now we need to solve both of these equations. And so we will get two answers. So I will add 5 to both sides. So this gives me negative z is equal to 30. And then I will divide both sides by negative 8. So z will equal 30 and 8 can both be divided by 2. So that will be 15 over 4. And this is negative because one of those was negative. So negative 15 over 4. So this is one answer to this equation. Now the other answer, I add 5 over again. And this will give me negative 8z is equal to negative 20. And then I'll divide both sides by negative 8. So z is equal to positive 5/2, because both of those can be divided by 4. And both were negative, so that'll give me positive. And so that's my other answer. So as long as the absolute value is equal to a positive number, you should always get two answers. And you can plug those back in and check, but it's not mandatory. It will work. If you did the work right, it'll work. Okay, number 11 is also from section 2.1. And this says to solve the following formula for the indicated variable. So this is P times V is equal to N times R times T. And they want me to solve for T. So they want me to take steps to get T by itself. Now, even though this is all letters, we're still going to use the same exact algebra rules. So because N and R is being multiplied by the T, which is what we want to get by itself, we want to get the T by itself, I'm just going to do the opposite operation here. That's what you always do, opposite operation. So I need to get rid of this N and the R, and it's being multiplied by the T. So I need to divide by N and R to cancel it. And then what I do to one side, I have to do to the other side. So that gets T by itself on the right. And this is just equal to P times V divided by N times R. And that's it. I can't do anything else because I don't know what any of those letters are. But I did solve for T because I got it by itself. Okay, number 12 is from section 3.4. And this says to find the equation of the line in slope-intercept form that passes through the following point with the given slope. So I talked about this in the last video. As long as you have a point and a slope, you can find the equation of the line. Excuse me. By using the point slope formula. So this is the point slope formula here, where m is the slope and the x1, y1 is going to be the 9 and the negative 12. So 9 will be x1, negative 12 will be y1, because that's the point that lies on this line. So I'm just going to plug this information into this form. So this will give me y minus, and then y1 is negative 12, so that gives me a double negative there, is equal to 3, the slope, times x minus x1, which is 9. And then they want this to be in slope-intercept form, which, remember, is y equals mx plus b, so that means I need to get y by itself. So first I'm going to simplify these two negatives, so that'll give me y plus 12. And then distribute the 3 on the right, which will give me 3x minus 27. And then the last thing I just need to do to get y by itself is subtract this 12. So y is equal to 3x minus 39. And that's the final answer. So you can always find an equation of a line using this form if you have a point and a slope. And then you just solve for y to get it into this form, which is the slope-intercept form. Okay, and then the last question, number 13. This is from section 3.6. Which is about solving linear inequalities, two linear inequalities. I don't love the way that the book did this, so I only put one of these on the exam. And I made it will be a and question, not a or, because that's what I want us to focus on. But to graph this entire solution, it's gonna break it up into parts for you. So the first step, they're gonna ask us to graph the solution set of the first linear inequality. So this one, so 2x plus 4y is less than 8. And to graph this, you can either get it into slope-intercept form by solving for y, or you can do an xy table. I'm just going to do an xy table and find the x and y intercept. So I'm going to let x be 0 and plug 0 in for x and find out what y is equal to when x is 0. So 2 times 0 is 0, which leaves me with 4y is less than 8. Divide by 4. So y is equal to 2. Now again, you can replace this with an equal sign while you're finding points. That inequality doesn't really matter here yet. Okay, and then the next one, I'm going to let y equal 0. Which will find us our x-intercept. So I'm going to solve for x, so that zeroes out the 4 times 0, which leaves me with 2x is equal to 8. Divide by 2. And x is equal to 4. Okay, so this found me the point 0, 2, and this found me the point 4, 0. So I'm going to go ahead and plot those 2 points. And then I need to determine whether this is dotted or solid line, because it is an inequality. So remember, up here, this is strictly less than. It cannot equal. So the line will be dotted or dashed. So this will be a dashed line because it cannot equal. And then we need to determine whether or where to shade. So there's always three things you need to do for inequalities. You need to find 2 points in order to graph it, determine whether it is dotted or solid, and then test a test point to determine whether where to shade. So again, I'm going to test the point 0, 0. You do have to pick a point that's not on the line. So if your line goes through the origin, you can't pick 0, 0. But otherwise, I would just always pick 0, 0. So 0, 0 is, that point is right here. So if I plug in 0, 0 to this inequality and it's true, I'll shade that half. If it's false, I'll shade this half. Okay, so I'm going to plug 0 in for x and 0 in for y. So 2 times 0 plus 4 times 0 is less than 8. Is that true? Well, everything on the left will just become 0. 0 plus 0 is 0. And 0 is less than 8, so that is true. So I will shade the side where 0, 0 is on. There's only 2 sides to this line, the bottom or the top. So because the point I chose is on the bottom of that line or to the left, and it was true, that's where I'm going to shade for that line. Okay, so you always have to graph the line, determine whether it's dotted or solid, and then determine which half to shade. Which half of the x and y plane do you shade? By using a test point. Okay, step 2, we're going to graph the other one, which is x is greater than or equal to 2. So this is going to be a vertical line because there's only x, no y, and it'll be a vertical line at x equals 2. So 1, 2, here's x is 2. So vertical line means you go up and down, and this will be a solid line. Since x can equal 2 because of the inequality symbol. It's greater than or equal. So this will be a solid line up and down. The reason why it's a vertical line is because x always has to be 2. That's it. There's no other, all the points on this line has to be equal to 2. And then we determine where to shade. So also if it's just one variable, it's easier because this says x has to be greater than or equal to 2. Well, x is the horizontal axis. So all numbers that are greater than 2 on the x-axis will be to the right. So that'll be here. If it was less than, I would have shaded to the left of that line. So that's it for step 2. Now, step 3, we are going to combine and graph the entire set. So let me remind myself of these points, 0, 2, 4, 0. And then x is 2. And that one's solid. So I'm just regraphing them on the same graph system. Okay, now because the original problem here had the word and, when I go to graph the final solution to this problem, it's going to be the intersection of these two graphs that I just did, because it has to be true for both. So I graphed this side of the dotted line, and I graphed this side of the vertical line. So the part where they overlap, where it's darker purple down here, this is actually the only place I'm going to shade, that one region. So the final answer will only be shading this region for the entire solution, because I'm only interested in the region that makes both of these true. They have to both be true. And this problem right here would be the solution is the intersection of the two graphs. And this would be the final answer for the entire problem. So they break it up into parts for you, which is nice, so you can kind of see what you shade for both. But if that is an and, then you only do the intersection. If it was or, then it would be the union. But I'm less concerned about or for these problems here. Okay, and that's going to be it. I know that was probably a pretty short video because I got a little cut off on the last one because I had somebody come over to my house unexpectedly. But I will upload both of these today. Please make sure that you have made a testing appointment and that you are getting caught up on your work. And these files, the completed notes for these two reviews, are going to be uploaded to files under Canvas so that you can see the notes I did as well. Let me know if you have any questions or if you'd like to meet via Zoom. Thank you.